Okay, we have introduced that a derivative may actually be a function and not just a value. So we're going to extend that idea. If we can come up with an equation, we should also be able to generate a graph. So this example, I'm going to go from graph of a function to a graph of a derivative. And notice there are no values on my graph, so we're just going to make a rough drawing. Very, very rough drawing. However, there are some very important concepts here. As we move from the left to right, my rate of change is positive. I'm going up. I'm going up. I'm going up. I'm going down. Positive rate of change, negative rate of change. Positive, negative, positive. To go from positive to negative, at some point, we had to hit the highest point inside that curve. And at this x value, we can say that my instantaneous rate of change should be approximately 0. If I drew a tangent line there, it should be a horizontal line. I'm going to plot that x and y value. Well, we know where the x value is. It's this x value. This is an x value. I'll just call it one x value that I'm interested in. And the y value that I'm now going to talk about is going to be on the derivative function. So I've got a instantaneous rate of change here that is 0. So for that one x value, I will have a y value of 0. And I'll plot that point. There's the x value, there's the y value. Let's take this second x value. Okay, along here, my function is decreasing, 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 increasing, increasing. So decreasing, increasing. And somewhere along the way, approximately here, it stopped going down and started going up. So my instantaneous rate of change went from negative to positive because it went through 0. So this is also going to be an easy point to find on the derivative function. At that x value, I know the output is 0 because that's my instantaneous rate of change of my function. Now, over here, my instantaneous rate of change are all positive. Over here, negative. All over here, positive. This is a smooth, continuous function. Things do not change really quickly. It's positive, less positive, less positive, less positive, less positive, 0, a little negative, more negative, more negative, more negative maybe, less negative, less negative, less negative, 0. So let's just talk about in here. More negative, more negative, more negative, less negative, less negative, less negative, 0. So I have to start at 0, and as I'm on my derivative function, I must go more negative, more negative, more negative, more negative, less negative, less negative, 0. On this part of my function, my rate of change, my instantaneous rate of change is positive, positive, positive. So less positive, less positive, less positive, less positive, 0. If I was to go backwards, 0, more positive, more positive, more positive. Again, when I'm talking about positive rate of change, it's always describing as I come from left to right. Even though I'm physically moving to the left, my rate of change is never affected by that. This function has a positive rate of change here, and it's more positive, more positive, less positive, less positive, less positive. So as I go to here, it's becoming less positive, less positive, less positive, less positive until it hits 0. As I move past x2, this function's rate of change is becoming more positive, more positive, more positive, more positive. So I'm past x2, more positive, more positive, more positive, more positive. This would be a rough graph of my derivative function. Let's try another one. So here's a function, and as I move from left to right, this function is going up, positive rate of change, positive rate of change, but less positive, less positive. It's less steep, less steep, less steep, and right around here it seems like it flattens out, which means horizontal. So horizontal here, and if I continue though, it starts now going positive slope, or positive rate of change, positive rate of change, positive rate of change. So approximately this 1x value is going to have a rate of change that appears to be 0 on the function. Everything else is positive. So let's move past this point. More positive, more positive, more positive, more positive. Over here it was less positive, less positive, less positive, less positive, 0. So here is approximately, more or less, my derivative function. And again, I'll continue with more examples. This is an interesting function here. This might be a good example of an absolute value function. So what I really have is two rays, two pieces of a line, one going to the left, one going to the right from this point. And a line, its instantaneous rate of change is called its slope. So when I draw the derivative, let me label this as my function. When I draw the derivative, we notice something interesting is happening at this x value. But let's think about this. Let's say this slope here is some negative number, but it's constant, which means if it was, let's say, negative 2 over here, it would still be negative 2, it would still be negative 2, it'd still be negative 2, negative 2. And I'm just going to put an open dot here right now. But everywhere over here, sorry, my line's quite ugly. Let me try erasing that and making it pretty. This would represent that constant slope of a straight line, and I have at least a piece of a line over there. But when I get to this side of the function, again, this is a piece of a straight line. Its slope is going to be a constant value, and it appears to be positive. Same positive as this is negative, more or less. So again, I'm going to start with an open dot there and go to the right as a constant value. And this is my derivative of that function. What's interesting about this graph is what you notice is my derivative function is not connected, because at this point here, is my function increasing or decreasing? And if I was to zoom into that point and think, well, maybe I can figure it out by zooming in, well, it doesn't look any different. No matter how much you zoom in, it's still a sharp angle. I go from going down to immediately going up. There is no transition. So this is not a smooth function because I have a point, and this point is a vertex, but again, it's a point. It's not smooth. So what we end up with is actually having no derivative at this point here. So this point is not differentiable, but every other point on the function is, because all the other points are part of a line. And side will have a constant slope. So I have this positive constant slope and this negative constant slope that doesn't change.